Welcome to another deep dive. Today, we're going to be tackling DeepSeek R1, this new open source AI model that's been making some waves for its reasoning capabilities. And what makes this so fascinating is it's not just open source, it's also going toe to toe with, those big names like OpenAI.
Yeah, I think what's really interesting here is that DeepSeek R1
Mm-hmm.
is sort of showing that you don't need these massive resources
Mm-hmm.
to play in the big leagues of AI.
Right. Yeah. It's like suddenly the playing field's
You know,
a bit more level. So to get to the bottom of this, we've got kind of a mix of sources here. We've got the technical stuff from their GitHub, and then a deep dive Medium article, and then even a more casual explainer too. Kind of tie it all together. But by the end of this, you're going to have a solid understanding of how DeepSeek R1 works, how it was built, and what it all means. You'll have a real advantage in understanding this corner of AI.
Yeah, I think
Yeah.
for the listener, what will be
Okay.
really useful is understanding how this model was trained
Mhm.
and the different approach that they've taken.
Yeah.
The training is compared to
Yeah.
what we've seen before.
Okay, so let's start with the basics. DeepSeek R1. What is it in a nutshell?
So essentially, DeepSeek R1 is a large language model, but with a specific focus on advanced reasoning. So, think complex math problems, writing code, logic puzzles, that kind of thing.
So it's not just spitting out text, it's actually thinking things through. But here's what really caught my eye, this whole pure reinforcement learning thing. What's the deal with that?
Yeah, so this is one of the kind of real breakthroughs here. With DeepSeek R1, most models rely heavily on what we call labeled beta. So these huge data sets where everything is tagged and categorized. DeepSeek R1 flips the script and says, actually, no, we're going to primarily use reinforcement learning, meaning it learns by doing and getting feedback,
Yeah.
not by being spoon-fed examples.
Hold on, that sounds like a massive leap. So how does that even work in practice?
So it starts with, actually, their initial version, DeepSeek R1.0. They used a framework called GRPO, which stands for Group Relative Policy Optimization. And imagine it like this. Instead of having a teacher tell the model what's right or wrong, it learns by comparing its performance to a group of responses and figuring out which ones are better.
Okay, I'm starting to see how that ties into the whole democratization of AI idea. They're not relying on these massive labeled data sets that only giant companies can build.
Precisely, and this is where things get interesting. So DeepSeek R1.0,
Yeah.
while groundbreaking, had some quirks, especially with readability. It would sometimes mix languages, have odd formatting.
Yeah, the explainer mentioned that. So it was brilliant, but a bit rough around the edges. How did they refine that for
Yep.
DeepSeek R1?
So they actually took a multi-stage approach to training. So first, they introduced a small amount of what they call cold start data, basically well-formatted examples to guide the model towards more readable outputs.
So it's like giving it a little primer on good writing before letting it loose.
Exactly. Then they layered on the reinforcement learning, but with a twist. They use something called rejection sampling. So the model generates multiple responses, but only the ones that pass a quality check in terms of readability and formatting are used for further training.
So it's like a built-in editor that's constantly pushing for better output.
Exactly.
But here's what really struck me, is that they then use this technique called distillation to transfer that reasoning power to smaller models like Qwen 7b and Qwen 32b. Why is that so important?
Yeah, this is huge because it makes
Yeah.
this level of performance accessible to a much wider audience. Because
Right.
these smaller models, they don't need a supercomputer to run.
Right.
So suddenly you've got
Yeah.
researchers, developers, even smaller businesses
Yeah.
who can tap into this level of AI.
So it's not just about building a powerful model. It's
Yeah.
about making that power usable.
And by combining these techniques, they not only solve the readability issues, but also manage to achieve performance that is on par with, or even exceeding, those big proprietary models.
Hold on, exceeding. Let's get into those performance highlights, because this is where things get really interesting for our listener, right? They want to know how this stacks up against the competition.
Absolutely. And the results are pretty impressive, especially when you consider how they achieved them. So let's start with ANM 2024. So ANM, that's a tough math competition for high schoolers, right?
Not your average math test. And DeepSeek R1 kind of nailed it. They achieved a pass at one score of almost 80%, meaning it got a significant chunk of those problems right on first try.
Yeah, and to put that in perspective, it actually beat out OpenAI's model 01-12-17 on that benchmark.
Okay, that's a serious win. But math isn't everything, right? What about stuff that requires understanding longer pieces of text, like can it handle a dense research paper or a news article?
Yeah, so that's another strength. They tested it on benchmarks designed for what we call long context understanding. So things like, Analyzing documents,
Yeah.
summarizing complex info, drawing inferences from a lot of text. And DeepSeek R1 consistently outperformed other models, even its own predecessor, DeepSeek V3.
So it's not just a one-trick pony. Now, the explainer mentioned frames and arena hard. What were those testing?
Yeah, so frames is all about how well a model understands information presented in a structured way, like a database. And then arena hard is kind of like, no, I'm throwing a mix of tasks at it. So things like question answering, summarization, even creative writing.
What kind of performance are we seeing from these distilled models?
Yeah, so they're punching well above their weight class. So Quen 32B, after being distilled with DeepSeek R1's knowledge, got a pass at one score of over 72% on that AIM test we talked about. And on Math 500, another challenging benchmark, scored 94.3%.
Wow, so they're not just inheriting some basic skills. They're getting a real boost in reasoning ability.
Right, exactly. And it's not just about hitting high scores. They're proving themselves in practical areas, too. So the distilled Quen 32B did incredibly well on Live Code Bench, which is a benchmark that tests how well a model can actually generate working code.
Okay, so this is starting to feel really significant. We're not just talking about academic exercises. We're talking about AI that can build real-world solutions. What does that mean for, say, someone who's listening to this deep dive right now?
But think about it. Running DeepSeek-level AI on your phone or laptop. Suddenly you have access to incredibly powerful tools for things like personalized education, local business analytics, even creative tasks you hadn't imagined before.
That's a game changer. But before we get too carried away, let's talk about the journey.
Right.
Building something this groundbreaking, there had to be some challenges along the way.
Of course, innovation is never a straight line.
Right.
And they hit a few roadblocks. And those actually led to some valuable insights. One of the early hurdles, as we mentioned, was that readability issue with DeepSeek R1.0.
Yeah, the whole English to Chinese switcheroo thing, not exactly ideal for user-friendly AI. What else did they run into?
So they initially explored using what they call process reward models, or PRMs. And the idea there was to kind of guide the model by rewarding it for taking specific steps towards a solution.
Interesting. So it's not just about the final answer. It's about the thought process that gets you there.
Exactly. But it turned out to be really hard to define those steps across a wide range of tasks. It was like trying to come up with a universal set of rules for problem solving, which is incredibly complex. And then there's the challenge of actually teaching the model those rules.
I can imagine that getting pretty messy. What about the other approach they tried, the one inspired by AlphaGo?
Right. So that involved using what's called Monte Carlo T-Search, or MCTS. And it's a way of systematically exploring different solutions. But it became incredibly complex when applied to language. Because you're dealing with text at the level of individual words and a punctuation mark. So the number of possible combinations explodes exponentially.
So computationally, it was just too much to handle.
Yeah, it was like trying to map out every possible route through a maze that kept growing and changing.
Okay, so they had to find a different path. What were some of the key takeaways from those early challenges?
I think a big one was the importance of balancing complexity with practicality. They needed solutions that were not only effective, but also efficient to implement and scale. And that's where those innovations we discussed earlier, the cold start data, rejection sampling, and language consistency rewards really made a difference.
So they learned from those setbacks and ultimately found a more streamlined and effective approach.
Exactly. But the journey isn't over. They've outlined some ambitious goals for the future, further improving general capabilities, addressing those remaining language mixing quirks, and making the model even more responsive to different types of prompts.
Now that you mention it, I am curious about those general capabilities. What are they hoping to achieve there? What's next on the roadmap?
Well, one area they're really focused on is improving the model's ability to handle those back and forth conversations, those multi-turn interactions that are so natural to human communication.
Right. Makes sense. Like if you're going to have an AI assistant, you want it to be able to follow a conversation, not just respond to isolated commands.
Exactly. And remember those language mixing issues we talked about?
Yeah.
They're exploring a couple avenues there. One is incorporating more diverse language data into the training process, so the model's exposed to a wider range of linguistic patterns.
So it's like giving it a more well-rounded language education.
Right. And they're also working on language-specific alignment techniques, basically fine-tuning the model to maintain consistency within a given language.
Okay.
No more surprise language switches.
So that's language mixing. What about prompt sensitivity? Why is that so important?
Well, you want a model that can understand your intent, regardless of how you phrase your question or instruction.
Right. So it's not just about recognizing words. It's about understanding meaning and context.
Precisely. And then there's this whole area of scaling the model's capabilities in the realm of software engineering. So they're exploring things like asynchronous evaluations during training to make better use of computational resources. And they're looking at ways to leverage rejection sampling and curated data sets to kind of accelerate the model's learning.
It sounds like they're really pushing the boundaries of what's possible with DeepSeek R1 in the world of software development.
Absolutely.
Yeah.
And they're not stopping there. They're also refining those distillation techniques we talked about, figuring out how to make them even more effective and adaptable for use in resource-constrained environments.
Imagine running this level of AI on a mobile device.
That's incredible. So they're not just aiming for bigger and better. They're also thinking about accessibility and real-world applications.
It's refreshing to see a team that's not just chasing benchmarks, but also thinking deeply about the responsible development of AI. And, this commitment to transparency and open sourcing, it feels almost radical these days.
Yeah, it is a significant departure from the norm. And I think that's what makes DeepSeek's approach so potentially transformative.
Right.
By opening up their models and their research, they're fostering collaboration and really accelerating the pace of innovation.
Right, and that speed is evident in their progress. An explainer pointed out that they actually managed to match OpenAI's O1 performance in just a couple of months, even without knowing the specifics of their training methods.
Yeah, that's pretty remarkable. It speaks volumes about their approach and
Yeah.
their team's dedication. They've proven that. You don't need massive resources or a culture of secrecy to achieve groundbreaking results.
So let's bring this home for our listener. Why should they care about DeepSeek R1 and what it represents?
Well, this is about more than just impressive technical achievements. It's about the potential of AI to fundamentally change the way we work, learn, and solve problems.
It's about empowering people with tools that were previously unimaginable or simply out of reach.
Right, think about it. What if you had access to an AI assistant that could help you write better code, analyze complex data, or create compelling content? And what if all of that was available without needing a huge budget or a degree in computer science? That's the kind of future DeepSeek is helping to create.
It's about democratizing access to cutting-edge AI and unlocking possibilities for everyone.
And it's about cultivating a more open and collaborative approach to AI development, where knowledge is shared and advancements benefit the entire community.
This deep dive has been a revelation for me. DeepSeek R1 is not just another AI model. It's a glimpse into a future where AI is more powerful, more accessible, and more aligned with human values.
A future we can all be excited to be a part of.
Absolutely. So as we wrap up, we want to leave you with something to think about. Could DeepSeek's transparent and collaborative approach become the blueprint for AI development going forward? Could this spark a movement toward a more democratized and accessible AI landscape?
It's a question worth pondering. The future of AI is being shaped right now, and everyone has the opportunity to play a role.
We encourage you to explore the resources we've provided, delve deeper into the world of DeepSeek R1, and maybe even experiment with the model yourself.
Who knows, you might just discover your own unique way to contribute to this exciting field.
That's all the time we have for today's deep dive. Until next time, keep exploring, keep learning, and keep pushing the boundaries of what's possible.